All right, day 6 homework. We are learning about the normal curve, which looks like this. And the bottom line is you really want to memorize all of these little numbers on this curve, including these 3 percentages down here. Okay, we will be referring back to these. But let's get started for right now. Okay, so looking at problem number 1. All right, the annual rate of return on a stock on stock indexes is approximately normal, okay, which means it makes a bell curve. Since 1945, the S&P 500 index has a mean yearly return of 12%, with a standard deviation of 16.5%. Take this distribution to be the distribution of yearly returns over a long period. So draw an accurate sketch of this distribution of annual rates on stock indexes. Be sure to label the mean, etc. Okay, so here is what we are talking about, my friends. So you should draw yourself a nice bell curve as best you can, all right? And I mean, I'm not an artist. Maybe you're an artist, I don't know. But my point is, I'm not judging, okay? Just do your best here. Whoa. Okay, you gotta do a little better than that. Okay, just make your bell curve as best you can. Okay, now I would put one line right at the middle. That's your mean. And I would put 2 additional lines near the edges. Okay. Now, so the middle line, that's your mean. So it's a mean of 12%. So I'm just going to put a 12 right here. Okay. Now, before I do anything else, we need a few more lines in here. So on the right side, there should be 2 more lines in this space. Just try to space them out as best you can. Okay, just do your best. So 2 more lines in here, and same thing in here. All right, every one of these lines is 1 standard deviation over. So the standard deviation, we're told, is 16.5. So if I do 12 plus 16.5, let's see, plus 16.5, that's going to give me 28.5. And that's the next number over, okay, 28.5. And if I add that again, okay, so if I'm getting 45. And again, if I do plus 16.5, I'm getting 61.5. All right, and I'm going to do the same thing in the opposite direction. All right, each one of these is 1 standard deviation away, only now I am subtracting. So if I do 12 minus 16.5, I get negative 4.5. Okay, minus 16.5 again, I get negative 21. And minus 16.5 again, I get negative 37.5. Okay, now, so we have the mean, and we count up by the standard deviations and down. Now, you really want to memorize all of the numbers on this chart, okay? So just from memory, you should be able to fill in these percentages representing each portion of this graph. All right, for example, from memory, I know that this portion of the graph represents 34% of the data. And I know that the next portion is 13.5% of the data. Okay, the next portion I know is 2.35% of the data. And the last portion is 0.15% of the data. All right, of course, the left side is a mirror image of the right side, so I'm just going to copy it over. So 34%, 13.5%. But just like I knew those numbers off the top of my head, you should too. So just sit down and memorize those numbers, please. Do it now. Do it today. Why wait? All right, 0.15%. Okay, those are the key numbers that you need to know. There are also 3 more versions of these numbers that you need to know. Okay, I would highly recommend you memorize the following 3 numbers in addition. And here they are. Okay, if I go out 1 standard deviation in both directions from the mean, that is 68% of the data. 34 and 34, but just think of it as 68%. All right, on the other hand, if I go 2 standard deviations out, all right, so here's the mean. So if I go 2 standard deviations in both directions, that is stretching from here to here. Well, that is 95% of the data. Okay, so 1 standard deviation, that's 68% of the data. 2 standard deviations, that's 95% of the data. And 1 more, if I go 3 standard deviations in both directions. So please understand, if I go 1, 2, 3 standard deviations to the left, and 1, 2, 3 standard deviations to the right, that's almost the whole graph. All right, it's everything except for these little pieces on the ends. Okay, so that's going to be very close to 100%, but not quite. And in fact, if I do 3 standard deviations in both directions, that is 99.7% of the data. All right, these numbers are in your notes, okay? 68%, 95%, 99.7%. All right, 1 standard deviation, 2 standard deviations, and 3 standard deviations in both directions. All right, on with the show. So I'm looking at part B. In what range do the middle 95% of the values lie? Okay, well, the middle 95%, that is 2 standard deviations in both directions. So what I just highlighted in yellow there, that's the middle 95%, 2 standard deviations. Okay, so that is from -21 to 45. Okay, so in this case the data happens to be in percentages. That's not usually the case, but between -21 and 45. And you can write your answer in interval notation if you want, like this, -21 to 45. Okay, what else? What percent of yearly returns are greater than -4.5%? Okay, so you see -4.5% is right here. Okay, so greater than that would be like this, from here forward, all right, this whole thing. So you could add up all of these percentages, but if you start counting from here, if you look at everything to the right of the mean, that's 50% of the data. So really all I need to do is add in this extra 34%. So I'm really just doing 50% plus 34%. That is 84%. Okay, it's the quick way to do it. Okay, so 84%. Now, what percent of yearly returns fall between 28.5 and 45%? Okay, so I'm looking for 28.5 and 45. Oh, well, that's right here. Between 28.5 and 45, that's 13.5%. That's one of the numbers that we memorized anyway. Okay, a yearly return of negative 21% falls at what percentile? Okay, first let's find that number, negative 21. Okay, so I found it. When we talk about percentiles, we're talking about the percentage of the data that is less than. So if I'm at negative 21, all right, this is the part of the curve that's less than 21. All right, so this less than amount tells us what percentile this is. So negative 21 is greater than, let's see, if I add these two numbers together, 0.15 and 2.35, what I get is 2.5%. That means negative 21 is the 2.5 percentile. Okay, just count up. It's sort of like a less than or equal to this number. Okay, it's 2.5% in this case. All right, so 2.5. I feel like I should put it 2.5 percentile. All right, normally we talk about the 90th percentile or the 80th percentile or the 50th percentile. So I wasn't sure what to do with my TH, but I'm comfortable with 2.5 percentile. Okay, let's move on. Many companies grade on a bell curve to compare the performance of their managers. Okay, hold on. All right, so let's suppose a company's performance scores are normally distributed, meaning bell curve. Managers with scores of 25 were 2 standard deviations below the mean. All right, you know what? Let's get our picture going before I read any more. I feel like I should zoom out a little bit. All right, let's get our picture going first of all. So, again, draw yourself a bell curve as best you can. Okay, 1 right down the middle and 2 near the edges. Okay, and then in between, put an extra couple. So boom, boom, and boom, boom. All right, that is how you get started. So of course, this is the mean right here in the middle. This is the mean. Okay, and these are all standard deviations away from the mean. So, okay, this year, okay, managers with scores of 25 were 2 standard deviations below the mean. So if I go 2 standard deviations below the mean, so 1, 2, that should be 25. All right, so there's my score of 25, 2 standard deviations below the mean. Okay, and managers with scores of 475 were 3 standard deviations above the mean. Okay, so 3 standard deviations above the mean. So 1, 2, 3, and this was 475. All right, what are the mean and standard deviation of the company's performance? Okay, well, let's see how many standard deviations these two are apart, and then divide. Okay, so first of all, the total difference between 25 and 475. So in other words, what is 475 minus 25? Okay, you can do this in your head. This is 450. Okay, so that's how far apart these are. All right, they are 450 apart. Now, this is 1, 2, 3, 4, 5 standard deviations away. Okay, so we need to do 450 divided by 5. Okay, that is 90. All right, so if I take this entire 450 and divide it into 5 jumps, that is a jump of 90. So it's like 90 plus 90 plus 90 plus 90 plus 90. Not sure why I put the plus on that last one and not the others. I guess I'll do it this way. That gets you up to 475. All right, now these jumps are all, that's what the standard deviation is. Okay, every one of these jumps is standard deviation. So that tells me that the standard deviation must be 90. Okay, so fine, the standard deviation is 90. And while we're at it, we can figure out what the mean is by starting from 25 and adding 90 twice. Okay, so let me go backwards a little bit now that we figured some stuff out. Okay, so if I go up by 90, that's going to give me 115. All right, if I go up by 90 one more time, that's going to give me 205. So that is my mean. Okay, so the standard deviation was 90 and the mean was 205. Okay, all right, that's all we needed for number 2 there. All right, let's go on to number 3. All right, let's see, the scores of a reference population on the Wechsler Intelligence Scale for Children, the WISC, are normally distributed with a mean of 100 and a standard deviation of 15. Draw that mess, okay? So kabam, we draw it. All right, it's going to be something like this. Okay, your mean is going to be right here in the middle, so there's 100 for you. And let's see, put a couple of lines near the end, put a couple more in between, like so. Okay, these represent your standard deviation. So if standard deviation of 15, then of course that means this will be 115 and this will be 130, okay, and this will be this will be 85 and this will be 70 and this will be 145 and this will be 55. Okay, so all I did was starting from 100. I'm increasing by 1 standard deviation every time. So I'm adding 15 as I go up, and I'm subtracting 15 as I go down. All right, now find the probability that a child gets a score of 115 or greater. Again, memorize these numbers. So watch how I do this from memory. You be able to do the same thing. All right, I know that this is 34% and I know that this is 13.5%. And I know that this is 2.35%. And I know that this is 0.15%. Okay, if you have not memorized these yet, memorize them right now, today, right this minute. All right, just practice them. 13.5. All right, take out a sheet of scratch paper and see if you can draw this picture from memory. And just try again and again until you can do it every time. It will only take you a minute to master it. Okay, just got to put in the time, people. 2.35% and 0.15%. Okay, so there you go. So anyway, probability that a child gets a score 115 or greater. So 115 or greater is from here over. Okay, so just add up these three percentages. Okay, so you're doing 13.5 plus 2.35 plus 0.15. That is 16%. Okay, what percent of children scored below 55? Okay, below 55 is just that little guy right there. And that is 0.15%. Okay, we read it right off the chart. What percentage of children score between 55 and 130? Okay, so there's 55, and there is 130. Okay, so you can just add up all these numbers. It will be slightly quicker if you remember what I said about these three numbers right here. Okay, the 68, the 95, the 99.7. Because if I look at the 70 to the 130, okay, that is 2 standard deviations in both directions. So right there, I know that that is 95%. So if I remember that, then I just go 95 plus the extra 2.35. Okay, and that's going to be 97.35%. Okay, but if you did not remember about the 2 standard deviations being 95%, there's nothing to stop you from just adding up these 5 numbers. You'll get the same answer that I got. What probability that a student scores between 100 and 115? All right, 100 to 115, that's 34%. Okay, now when we talk about probabilities, all right, were they doing probability on this last one? No, they said percent. They said percent. Okay, usually when we talk about probabilities, we don't leave it as a percent. We usually change it to a decimal. Okay, so I'm going to go back and do that on all of these. So 16% as a decimal is 0.16. I'm moving the decimal point twice to the left. So this is traditionally, in a statistics class, this is how we would show the probability, as a decimal as opposed to a percent. Okay, if I move this twice, then that's going to be 0.0015, which is crazy small. Okay. Oh wait, that's a percent again. So look, all right, I got to be careful. If it says probability, give me a decimal, okay? If it says percent, just give me a percent. So here it says probability, so I switch to 0.16. These two say percent, so I'm just going to leave it as percent. This one says probability again. So because it says probability, I'm going to go 0.34 with it. Okay, see the subtle difference? I knew you would. All right, and that is it for this lesson. Okay, relatively short, I'll take it. All right, I hope this video was helpful, and I will see you on the next video. Be helpful, not hurtful, my friends.